In the diagram, which is not drawn to scale, the points A, B, C, and D are on the circumference of the circle. O is the center of the circle, and ST is the tangent to the circle at the point A. BD is the diameter. The angle SAB is equal to 48 degrees, and the angle CBD is equal to 26 degrees. And here we have the diagram. Here, our goal is to find the angle ACB. Now here, notice that we have ACB, all right? ACB. And our goal is to figure out what is the size of this particular angle, right? Angle C, because that's the one in the middle. In order to do this, we're going to use the alternate segment theorem. And the alternate segment theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. Notice that we have this angle right here, which is called theta. And this angle, theta, is equal to this angle, right? And the reason why they are equal is because this is the chord and this is the tangent. This is the angle formed between the tangent, this is the tangent, and the chord. And it says that the angle formed between the tangent and the chord is equal to the angle that is subtended by the same chord in the alternate segment. And so notice that this angle is subtended by the same chord because the legs of the angle rests on this chord. And so if we look at this angle measures 48 degrees, and this angle measures 48 as well. And the reason why that's the case is because of the alternate segment theorem. And so angle ACB is equal to 48 degrees. And the reason why is because this right here is a chord, right? This right here is the tangent line, all right? And so the angle formed between the tangent line and the chord is 48 degrees. And that's equal to the angle in the opposite, to the angle in the alternate segment, which is subtended by the same chord, right? So this angle is subtended by the same chord in purple. And we know that this angle is subtended by this chord that is in purple. Is because if you look at the legs of this angle, the legs of this angle rest on this purple chord. And so if this is 48 degrees, this is 48 degrees because the angle between the tangent and the chord is equal to the angle that is subtended by the same chord, right, in the alternate segment. And that's why this is 48 degrees. Next, we are going to figure out what is the size or what is the measure of angle AOB. So angle AOB. So where's angle AOB? Angle AOB. So they really want us to figure out what is the size or what is the measure of the angle in the center, right? So what is the size, right? What is the size or what is the measure of this angle, angle O, right? Now there's a theorem that is useful, right? So what is the size of this angle? Now there's a theorem that is useful here, and the theorem says that the angle at the center of a circle is twice the angle at the circumference. And so that means that if the angle at the circumference is x, the angle at the center is going to be 2 times x. And so in this case, the angle at the center, the angle at the circumference is 48 degrees. So the angle at the circumference, the angle at the circumference is 48 degrees. So that means that the angle at the center is going to be 2 times 48. And so 2 times 48 is definitely 96. And that's because the angle at the center is twice the angle at the circumference. If the angle at the circumference is x, the angle at the center is 2x. In this case, the angle at the circumference is 48 degrees. So the angle at the center is 2 times 48 degrees, which is 96 degrees. Next, we need to figure out what is the size of angle CAD. Angle CAD. CAD. And so if we label it, angle CAD. So if we notice carefully, we have C, A, and D. So what they really want us to figure out is what is the size or what's the measure of this particular angle right here. Like what is the size of this angle, all right? Now, in order to do this, we could use the bow tie rule, all right? And if you notice, this looks like a bow tie, right? And the bow tie rule just states that if this is 26 degrees, then this must be 26 degrees. We refer to the bow tie rule also as the theorem that is talking about the angles in the same segment. And so the idea here is that angles in the same segment are equal. The same idea here. So if this is theta because if you notice carefully, this this line separates the circle into two segments. So these two angles are in the same segment, so they are equal. Similarly, these two angles are in the same segment, so they are equal. All right, that's the bow tie rule, right? And so that means that angle, that means that angle, that means that angle CAD is equal to 26 degrees because this is 26 degrees and they are in the same segment. They're in the same segment. And so this is 26 degrees and this is 26 degrees according to the bow tie rule. Next, we have to figure out what is the size of angle DAT. Angle DAT. So angle DAT, what is the size of angle DAT, right? And so what do we know? Well, we're going to use the alternate segment theorem. And the alternate segment theorem says that the angle that lies between the tangent and the chord is equal to the angle subtended by the same chord in the alternate segment. So if you notice that this angle theta is between the chord and the tangent, and since it's between the chord and the tangent, we know that it's going to be equal to this angle here, which is subtended by the chord that is in green, okay? And so that means that if this is theta, then this must also be theta because they are equal. And if we look at the same thing, we have that, if we look at the same thing, we have that this right here is the chord, okay? The angle in purple is the chord. We also have, so this is the chord, and we also have, this is the tangent line, right? So you have the angle formed between the tangent line and the chord that's going to be equal to the angle that is subtended by the same chord. And we know that this angle, right, which measures 42 degrees, is subtended by the chord in purple because the legs of this angle rest on this purple chord. And so if this is 42 degrees, this must be 42 degrees. If this is 42 degrees, this must be 42 degrees because they are equal. And so angle DAT is equal to 42 degrees. And that's the angle, and that's the answer because of the alternate segment theorem. Next, we need to figure out what is the size of angle OAT. And angle OAT is going to be, let me highlight this. That's going to be this particular angle. This is angle OAT, angle OAT. So we're really looking for the size of this particular angle right there, right? I'm sorry, that is not right. We're looking for the size of, okay, I'm sorry, this is wrong. Angle OAD, not OAT, I'm sorry, angle OAD. So O, A, and D, okay? So we're trying to figure out, so O, A, D, right? So O, A, and D. So we're looking for the size of this particular angle right there, okay? So angle O, A, D, okay? Now, okay, so what we need to figure out is, all right, what is the size of angle OAD? Now, what we need to do is we're going to use this particular theorem, and the theorem says that the angle formed between the tangent and the radius is 90 degrees. And so here we have the radius, and here we have the tangent line, and the angle formed between them is 90 degrees. And the same thing is true, right? So this right here, this line, angle OA, is the radius. So let me make a note of that. So this line right here is the radius, right? And then this line right here is the tangent, all right? So the angle formed between the tangent and the radius is 90 degrees, right? That's 90 degrees. And so what that means is that 42 degrees plus 26 degrees plus this angle, right? Let's call this angle, let's just call this angle right here. Let's just call it angle B. So if we add B, angle B plus 26 degrees plus 42 degrees, we should get 90 degrees. And so that means that angle B is equal to 90 degrees, right? minus the sum of 26, right? 26 degrees plus, plus 42. And so what we're gonna do is we're gonna add these two, and then we're gonna take their sum and subtract it from 90 degrees. So we have a 90, right? 90 minus, what is 26 plus 42? Now 26 plus 42 is definitely 68. And so that means that angle B is equal to 68 degrees. And so we have that B is equal to, what is a 90 minus 68? 90 minus 68 is definitely 22. So we have that B is equal to 22 degrees. That's what B is. B is equal to 22 degrees. And so we have that this B right here is 22 degrees. That's what it's equal to. But, and so what we're gonna do is, let me erase some information here. Erase this, erase this, erase, 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 let me erase that, erase that. And so what do we have, right? We know that, and let me erase this too. We know that this angle, which is B, is 22 degrees. And one thing else we know that this whole thing equals to 90 degrees. All right, but we don't want the whole thing. We just want to figure what is the size of angle. Let me highlight it again. The size of angle O. So angle O, angle A. I mean the size of angle O, A, and D. So D is right there. All right, D is right there. So what angle we actually want? And we want to figure what is the size of this. Okay, that's the angle we actually want. So angle OAD will just be equal to 22 degrees, right? 22 degrees plus 26 degrees. And so it's going to be equal to 22 plus 26. And what is 22 plus 26? 22 plus 26, that gives us 48. But it's going to be equal to 48 degrees. And so what does that mean? That means that angle OAD, which is this particular angle here, is going to be equal to the sum of 22 and 26. And that gives us 48 degrees. And so that's the answer to this particular question.